Hello students. Today we have a very good question. Uh, I would say it's a purely advanced level question and highly conceptual. So, first of all, let's read the question. The question says a piston can freely move inside a horizontal cylinder. I have drawn the cylinder. I have shown this piston which can move here and there freely. Okay, and the cylinder is closed from both the ends. Yes, these are closed. Initially, the piston separates the inside space of the cylinder into two equal parts, each of volume V naught. So you can say that the piston is at the center such that both side volume is V naught as per the question, in which an ideal gas is contained. Means here we have an ideal gas and here also we have an ideal gas. Both the chamber, the volume is same, and the ideal gas is contained under the same pressure and same temperature. That means this chamber A, the pressure of the gas is P naught, temperature is T naught, volume of the container of the gas is V naught. This chamber B also P naught, V naught, T naught, right? Now, what work has to be performed in order to increase the volume of one part of the gas isothermally eta times when compared to that of others by slowly moving the piston? Okay, so look, for your reference, I have drawn two diagrams parallel to each other, right? So what we have done, initially this was the case, and then by the help of external agent or external force, I have shifted this piston or slided this piston this much. Means you can say this way, that this much of distance is x. Let's say this is a cross sectional area which is your A. So A into X, if I say area into X, that is volume, that we all know. So means we have shifted this much of X much of distance, whose volume means this segment, this portion's volume is V. So total volume will be how much? V naught plus V. And this segment volume will be V naught minus V. Say yes or no. Means we have shifted this much. Earlier it was V naught. This side whole thing was V naught. Even this side was also here V naught. But then when we shifted V times V unit, then this side volume will be V naught minus V. And the question says the final volume means this final volume is eta time the smaller volume. This final volume is eta time the smaller volume. Means the final volume will be V naught plus V. Say yes or no. That is eta times smaller volume, V naught minus V. This is the expression. Okay. So I will try to reduce time. Directly I'll write the expressions and all to save time. But it's your duty to derive the final expressions and all. So I'm writing, when you solve this line, when you solve this equation, V means, because V is a variable here, V naught was a constant which is given the question, V is a variable, and when you solve it, you will get V is equal to V naught into N minus 1 by N plus 1. This is the expression you will get. Okay, that you need to calculate by solving. Okay, anyway, so the question is very clear. We have slided the piston slightly in such a way that the final volume of the bigger chamber, is equal to the eta times the volume of the smaller chamber. That's clear. And we need to calculate the work done by the external agent. So obviously, suppose if I'm drawing the piston, this is a piston. So cross sectional area is A. So this side, when you have seen when the piston has moved this side, so the gas will be here. So the gas will apply the P2 pressure this side, and this here also we have gas that will apply pressure P1 this side, right? So means this side is P2, this side is P1, and I'm shifting and sliding the piston this side only. That means the external agent has to apply the force this direction. Say yes or no. So this is a force, but and this P2 and P1 the pressure. So if I multiply with the area, can I say that these are the pressure? And at any point the pressure, the force will be in equilibrium. At any point the forces will be in equilibrium, right? the piston will be at equilibrium. So can I say P2A is equal to P1A plus F? Can I say or not? So the concept here is, whenever you get a question like this, whenever you get a question like the piston is being moved slightly, slowly, and calculate the work done by the external agent. So the concept is, the key point is, always try to calculate the pressure, always try to calculate the external force, balance the force, calculate the external force, and try to write the expression of, as what I said try to write the expression of force, try to write the expression of force in terms of pressure, which is given in the question. Try to write the expression of force in terms of pressure. This is a key point, this is a trick, this is the concept. So you can clearly see that an external agent is applying a force in that direction, in the right direction, which is equal to, what? Tell me. F is equal to P2 minus P1 into A. So we have derived the expression of force in terms of pressure. So the external agent is applying the force in the right direction, and the piston is also moving in the right direction, right? That means work done is equal to, फॉर एक्सटर्नल एजेंट आप कैसे डिस्क्राइब करते हो फोर्स, आप वर्क कैसे डिस्क्राइब करते हो? आप कहते हो जिस डायरेक्शन में फोर्स लग रहा है उसी डायरेक्शन में अगर पिस्टन या ऑब्जेक्ट मूव कर रहा है तो वर्क डन उसी डायरेक्शन में हो जाएगा, आई मीन पॉजिटिव होगा, राइट? जिस डायरेक्शन में फोर्स लग रहा है और ऑब्जेक्ट भी उस डायरेक्शन में मूव कर रहा है तो द वर्क विल बी पॉजिटिव, करेक्ट, एज पर द कॉन्सेप्ट फिजिक्स. तो यहाँ पर भी तो यही हो रहा है. दिस इज द सेम थिंग हैपनिंग हियर. The force is applying on the right side and the piston is also moving in the right side. So can I say work is equal to P2 minus P1 into area. और आपने कितना मूव किया है? आप इसको सॉल्व कैसे करोगे? आप कहोगे कि सर we have slided to x distance. Let's say if you want to calculate the total work done, you again slide it to dx distance, and then you put the proper limits, integrate it with the proper limits, you can get the total work done. And if you remember, you have solved such kind of questions, especially in physics, where you take a small limit, let's say dx dy, and then you further integrate, and then you substitute the limits, right? You can recall such kind of questions, although we are discussing chemistry, but you might have solved such kind of questions in kinematics, in calculating center of mass, right? Moment of inertia and all. So you might be able to recall such thing that your teacher would have taught you, like move something like by x distance and dx distance, and then further you integrate, right? If the object is not uniform, non-uniform kind of, same thing we will do here. We will slightly shift the piston dx distance and then we will integrate it with the proper limit to calculate the total work done. Anyway, so what I said, that we have shifted for dx distance. This is nothing but this part is your force and this is distance, right? So you will integrate it to calculate the total work done. But area into dx, area is A is a cross section area, into dx, can I say A into dx is called nothing but dB, change in volume, very small change in volume. So the whole expression can be written as P2 minus P1 into dV, and we will put the limit. Now listen, the limit is, earlier the piston is here. So let's say this part is your origin, you can say. Origin means 0. Means this is your reference, the piston was earlier here. This is your origin, and then the piston has moved here, this much of distance. This x distance A, so A into x is equal to volume V. That's what I have written. That means initial volume you can say 0, and the final limit will be, upper limit will be V. Means you have to integrate from 0 to V. But V is a variable and I need to express the V in terms of V naught, right? And that's the reason I have given you the expression. वो expression क्या था? V in terms of V naught n minus 1 by n plus 1. इस एक्सप्रेशन से आ जाएगा। तो हमने v को इसमें इसके फॉर्म में एक्सप्रेस कर दिया है और इंटीग्रेट करने के बाद इसको सब्स्टिट्यूट कर देंगे। ठीक है, तो चलिए हम लोग चलते हैं इसके सॉल्यूशन पार्ट पर। हमने क्वेश्चन एक्सप्लेन कर दिया है, आगे बढ़ते हैं। तो ये रहा, you can see the diagram clearly. We will calculate the external force that we have calculated. We have moved x distance and then we have moved dx distance, small limit, and then we will further integrate, as you can see. Correct? All these things have been explained. So here, work external force into dx. So P2 minus P1 into ADX, which is equal to P2 minus P1 into dV. Now P2 and P1 are the pressure, and we need to express the pressure in terms of initial pressure and volume. And as we know that, as the question says, it's isothermal process, can we apply Boyle's law? Boyle's law say P1 V1 is equal to P2 V2, which means P naught V naught is equal to P1 into V naught plus B. क्या कहा हमने? P naught V naught is equal to P1, फिर से P naught V naught is equal to P1 into V naught plus V. और इस कंटेनर, इस साइड कंटेनर के लिए, चैम्बर बी के लिए, P naught V naught is equal to P2 V naught minus V. उससे P2 क्या आ जाएगा? P2 आ जाएगा P naught V naught minus V, और P1 क्या आ जाएगा? P naught V naught plus V. Correct? So if you have understood, I have written the expression, even ये भी लिख दिया. So we have got P2 and P1, and so P2 minus P1, इसको सॉल्व करोगे, सॉल्व करने के बाद आपको ये एक्सप्रेशन आ जाएगा, and then P2 minus P1 into dV. So P2 minus P1, that is this part, correct, that we have, since it's a constant, I have not this part, this part is a constant, so I have taken this outside. Then V by V square minus V naught square minus V square dV. Correct? This part is left over. Tell me if you have understood till this part. यहाँ तक समझ में आया? अब now you have to use a proper maths integration, indefinite integration. This downside, assume y, then dy is equal to 0 minus 2v dv, because this was a kind of constant earlier, so that's why it's 0. So v dv is equal to minus half dy. So v dv की जगह पर in place of v dv, can I substitute minus half dy? Say yes or no? And then further, when you solve this expression, you will get minus p naught v naught ln y. And what was y? Y was v naught square minus v square. उसको एंड में सब्सटीट्यूट कर देंगे. लिमिट हमारा क्या होगा? 0 से v, पहले ही बताया, आई हैव ऑलरेडी एक्सप्लेन्ड. मीन्स इनिशियल यू हैव टेकन 0 एंड द फाइनल v, मीन्स आप इस सेगमेंट में एक्सपेंड करा रहे हो, इतना ही एक्सपेंड करा रहे हो, यू हैव एक्सपेंडिंग दिस मच. So this v volume you have to expand up till, right? And then I have already written the expression of v in terms of v naught n minus eta minus 1 by eta plus 1. And when you solve properly, जब limits put करते हो, solve करते हो properly, ठीक है, then you will get final expression as this much. Hope it's clear. It was a very good question, I would say. It was a time taking, but yes, such concepts build, such questions build your concept. Such questions really build your concept. So you have to solve questions like this. Okay, so the right answer will be B. I hope the question is clear, doubts is clear. So thank you very much.